So here's another story time story for today, and it involves my first job, my very first job, my real job. It was a local company, manufacturer of analog drives and also an importer of AC drives. And it's a story about something which the managers knew about, consented to the wireman doing, and the wireman would do in order to fix a problem, which was when a wire needed to be moved in a panel, it would sometimes be too short. So what you need to do generally is replace an entire piece of wire. You don't generally splice a wire, you replace the entire piece of wire. So point to point it's one piece of wire. There's no joint in it. No point of failure gets created. So what they would do is pick a relay, or generally a relay, a plug-in relay, one which fits into an octobase usually, but it was often MY4 type relay as well. And often on these relays which have 2 or 4 contacts, you're only using one of them, so there's some unused spares. So they would use the contact of an unused contact, so that's an entire contact, a common, normally closed and closed, normally open, normally closed, common, the whole thing as a bridging point to join this wire to make it longer. So you're going from where the wire came from originally into a contact with a lug, and then going out of that contact to where it now needs to go, the change in wiring. So you're basically creating a joint by using a terminal on a relay base as a place to put in 2 lugs and tie them together. And that's not on an unused contact, and generally that's not a problem. But twice that went wrong. The first time I was retrofitting a stone cutting machine which is used for sawing granite into slab, which was at a stone yard where they were making slab for furniture and for tombstones and all sorts of stuff. This was on one of the either cross or long travel. It moves the machine. It was a circular saw, it wasn't a rope saw. So I needed to make quite some changes going from the analog AC drive to the new digital drive in the wiring, and that meant making a change to the way the emergency stop circuit was wired in. It meant adding an additional contact. No problem, there's a relay. We'll just use the normally closed and the common on this relay, which is available in our control circuit, which is a 24 volt DC circuit. The other circuitry in this, which was I think 220 volts or something like that for main contactors and so on, happened to be joined in. They'd done the splice on the emergency stop relay to get a wire that was too short longer. That's basically what they were doing, making a wire longer. So I did the installation, commissioned it, tested it, and finally decided to test the e-stop and push the e-stop, and the drive went bang. So had a look at what had gone wrong and found out what they'd done. Phoned the office and said, "Boss man, I've blown up a drive. This is what happened." And went and fetched another drive. It was fortunately local. Brought it back, installed it, fixed what had caused the problem, and that was the end of that. But it's not good. The second time, it was a big rope strander or twister. It's a rope making machine. It was a complete retrofit of the control system on this machine. It was a PLC controlled thing, and there's a whole bunch of drives. There's a whole suite of panels, and the PLC guy complained that he was getting zapped off the touch screen, the HMI. the metal surround was giving him shocks, and he got quite a bad shock the one day. And what it turned out was that this thing was sitting live at 300 volts. So tracing back through the 24 volt circuitry, which we discovered was sitting at 300 volts with respect to Earth. So the 24 volts itself was sitting at 300 volts, and it was DC. We found that they'd extended a wire once again by wiring it into an unused contact wall, so they thought, on a relay, and that had connected 220 volts into the secondary of the 24 volt DC power supply, and the diodes on the output would of course rectifying this mains voltage to 300 volt DC with respect to Earth. And this was quite a problem. It almost killed somebody, and it resulted in the HMI getting damaged that had to get replaced. So when you're wiring a panel, never ever join a wire. Never ever make it longer by using an unused terminal or something like that. If the wire has to be longer, you replace it. So that was an interesting story about my early career, where this went wrong. I twice had this happen, and what the consequences were. It resulted in property damage, and it nearly resulted in somebody becoming unlived. Not very good. So I'm an old guy, 51, so I've seen all sorts of interesting things in my time, and I get to talk about them and share them with you guys, and you guys get to learn from it. You get to hear about something interesting, and we have a good time here talking about engineering, and you get to look at my untidy office while I talk about this stuff. It's awesome. So thanks for taking the time to be here today for this little story. Hope you enjoyed it. Hope you learned something from it. Ladies and gentlemen, take care. Have an awesome day further, and I'll see you next time for interesting stuff or a story. Cheers.